everyone. We are on to our next section in our third chapter of AP Statistics. We are moving on to talking about a least squares regression. So if you recall, in our first section, we talked about what correlation was, how we calculate it, how we would describe and interpret scatter plots, and how we make them. So after this section, there's going to be a few videos. We're going to be able to interpret a regression line. Sometimes we call it a line of best fit. We're going to be able to actually calculate the equation for the least squares regression line. We're going to calculate these things called residuals. We'll interpret and construct residual plots, determine how well a line is fitting some observed data, and then also look at some computer output. So let's go back to our days of algebra and just remember, what is slope, right? If you're being more formal about it, slope would be considered delta y over delta x. That little triangle there is a delta. It means a change in y over the change in x. So what does it mean? So for example, say you go bowling, you pay $3 for shoes and then $4 per game. Your equation that represents that situation would be y equals 3 plus 4x. So what does that mean? For every one game you play, you're going to pay $4 and then you pay that one-time fee of $3. So, for our next one, so you go shopping. I've already spent $5, but then I want to buy bananas, and I know they're 50 cents per pound. So what would the equation be for that? Well, our equation there will be y equals 5 plus 0.50x. So in context, for every 1 pound of bananas I buy, I have to pay 50 cents. Per pound. Okay, so we'll keep that in mind, and we're moving into the statistics of regression. So what is regression? A regression line is used for lots of things. Okay, we use it to predict a value of y for a given x. Remember, x is our explanatory variable and y is our response. And y hat, that little caret on top of the y, we call him y hat. Y hat is going to be our predicted value of y, what we think y should be. Now, if you're looking in the textbook or in the calculator, your equation for your regression line is y hat equals a plus bx. All right? Back in algebra, we used y equals mx plus b. In the world of statistics, we use a plus bx, where a is the y-intercept, right? It's the predicted value for y when x is 0. And b is the slope here, right? It's the amount that y is predicted to change whenever x increases by 1 unit. Now, in AP world, it's basically the exact same thing, except we use b sub 0 and b sub 1, where b sub 0 is the y-intercept and b sub 1 is our slope. Okay? So our regression summarizes the relationship between two variables, obviously quantitative variables, but only in the setting where one of the variables helps explain or predict the other. If your data is not linear, you should not find the regression line. Okay? So it describes how the response variable y changes as the explanatory variable changes. Like I said, we use it for predictions. So you can see here, the scatter plot shows that there's a linear relationship, and that red line going through is called our regression line. Now, regression lines are used to conduct analysis. Okay, so colleges can use students' SATs and GPAs to predict their college success rate. Professional sports teams use players' vital stats to predict success. It's kind of how I survive in fantasy football every year. Macy's department store uses shipping, sales, inventory data to predict future sales, so on and so forth. All right. So, for example, we've been talking about body weight and backpack weight. All right. And we have our scatter plot here, and we have our data points, and this blue line is our regression line. All right, it's our line of best fit. That's our least squares regression line. So there's two different ways that you can write out your regression line. You can either use the variables y hat and x. All right, make sure you list your intercept first. If you choose to do it this way, you then have to define your variables. Let's say that. You have to define your variables. What does y hat represent? What does x represent? The other option, don't use variables at all and just use the words. That is perfectly acceptable as well. But you have to do either one or the other. Now, say you wanted to interpret. Okay, say you wanted to interpret your line of best fit. What does the y-intercept mean? What does the slope mean? So, in our instance here, talking about our body weight and backpack weight, our y-intercept of 16.3, how I would interpret that. A student that weighs 0 pounds is predicted to have a backpack of 16.3 pounds. Now, while I can interpret that, it doesn't mean it makes any kind of sense. Obviously, someone can't weigh 0 pounds and carry a backpack. They don't exist. But that's how you would interpret such a thing. To interpret our slope, for each additional pound that the student weighs, it is predicted that their backpack will weigh an additional 0.0908 pounds more on average. Please remember that on average, and the whole part about it that it's predicted. It's just a prediction. It might not be right. So we have to use the word predicted and on average in our interpretation of slope. So here's kind of a general sentence. Do you have to have exactly this every time? No, but it's kind of a good way to help yourself out if you're like, I don't know how to interpret. What do I do? So for every additional, whatever your x is, it's predicted that whatever your y is going to either go up or down this much on average. Y-intercept, you have to again mention that it's about for 0 and that it's predicted there. Okay? Sometimes they'll ask you, does this make sense? And then you have to use your best judgment to see if that y-intercept interpretation makes any kind of sense whatsoever for the context. Now, if you'll remember me saying we use our regression line in order to make predictions. So here's an example. We want to use our regression line to figure out the predicted SAT math score for a student who studied for 12 hours. So this equation right here shows me hours studied, and it will spit out or put out my predicted SAT math score. Okay? So all I want to do for 12 hours, hours is my x variable, my explanatory, the hours studied explains the score. All I would do is simply substitute in that value for x. So if you study for 12 hours, it is predicted that you would get an SAT math score of 714 points. That'd be nice. Now, you try this right here, right? Interpret the slope, interpret the y-intercept. Again, always in context. Answer, tell me, does it make sense? And then make some predictions for 2 different years. So we're talking about minimum wage. So if you want to pause the video or if you want to come back later and do it, but make sure you do this example. Now, when you're predicting, you do need to be a little bit careful. There's this thing called extrapolation. Extrapolation is when you're using a regression line to make predictions that are outside of the range of x values that you got your data from. It's not very reliable. If you already did that last example, you might see why. Okay. Now, interpolation is when you're using that regression line to make predictions inside the range of x values. It's going to be a little bit more reliable. You still need to be wary, but it's more reliable there. All right, let's look at another example together. So we have a scatter plot. It's showing the number of miles driven in thousands and advertised price also in thousands for 11 used Honda CR-Vs from the 2002-2006 models. We have our regression line shown here, and there is our line of best fit, our regression line equation. So interpret the slope and the y-intercept, make some predictions. Which prediction is going to be more reliable? So again, take a second, well, more than a few seconds, pause the video. I really want you to do this. Right? Don't just wait for me to go to the next slide and show you the answers, because I am going to. But I want you to try it on your own. How can I interpret these things? What's it going to mean? All right, here's our interpretations. Here's how we predict. Notice how I showed the work. That's important. And then we have a case of extrapolation. It's not going to make sense for 250,000 miles. Okay. Now, something else we can talk about. Residuals. What in the world is a residual? Well, a residual is the difference between an observed value of the response variable and the value that we predicted by the regression line. So it's the actual y that you have minus your predicted y. So if you remember AP, of course, actual minus predicted. It's whatever the true y is minus the y hat. Just like when we did z-scores. So some values will have positive residuals if it's above the line, right? Actual is greater than the predicted. Some values will have negative residuals if it's below the line. It's less than what the actual is less than what we predicted. So if you wanted to calculate one, you plug that x value into the least squares regression line, figure out what was the actual observed, and then you just subtract. All right, so it's just a subtraction. So if a student weighs 170 pounds and their backpack weighs 35 pounds, what's the value of the residual? Okay. Well, plug 170, because that's my x value, into my equation. The predicted backpack weight would be 31.736. The actual weight they told us was 35, so subtract actual minus predicted. And we can then interpret our residual. The student's backpack weighed more, 3.264 pounds more, to be precise, than was predicted. Well, what if the student only weighed 105 pounds and their backpack weighed 24 pounds? Same deal. Plug in 105, because that is my x. Okay? And then find your predicted. They told us the actual. Do some subtraction. Actual minus predicted. A minus P. And we find that it's a negative value. So this tells me my backpack weighed less than I predicted. Right? It underestimated it, if you will. Okay? Weighed less than I predicted. Well, actually, I overestimated it because the actual weight is less. All right. One more for you guys to do for yourself. We have some data here. We were talking about male white laboratory rats for the first 25 weeks after birth. We have our regression equation. We want to make a prediction about the weight, calculate and interpret the residual, and then answer me this. Should we use this line to predict the rat's weight at 2 years old? Press pause. Try it out. All right. Our results. Predicted. We predict it's going to be 740 grams. The residual is 40, so it means it would weigh less than our predicted. LSRE stands for least squares regression equation. Least squares regression equation. It's just the line of best fit. This thing up here. This y hat equals is my least squares regression equation. Should I use it? No. It's not in the data set. It's probably not valid. Now, you might be wondering why we call it a least squares regression line. It literally has to do with squares. It's kind of cool, right? Different regression lines produce different residuals. So the one that we use here is our least squares regression. We do it because we want the sum of the squared residuals to be as small as possible. It's a really interesting concept. I can show you more and include some more links as well. In our next video, you're going to learn how we actually can calculate the equation if it's not given to you, as well as some other fun stuff. Stay tuned.